now before we go into more graphing is this do now question. So if you can pause me and try it and see what you come up with and then turn me back on and we'll see how you did. Okay, so I hope you pause me. And let's take a look at what we got here. When I look at this to me is a mess, 2 to the 2x plus 2. I'm going to change this. This becomes 4 to the 2x minus 5. And I'm going to take this piece to the right and break it up into 2 to the x times 2 to the 2x times 2 squared. The reason why you can do that is, now let's look at this. If you're multiplying two things with the same base, what are you allowed to do to the exponents? Add them. So this is just doing that rule backwards. So if you didn't know how to start it and you got here, see if you can pause me and see if you know what to do next. Okay, so let's see if you knew what it is we have to do. There's two options here. This is 2 squared, right, to the x. So this is 4 to the 2x minus 5. This would be the same thing as saying 4 squared to the x times 2 squared, right? Well, what is 2 squared? This is 4 to the 2x minus 5. This would be 4 to the x times 4. And what this question is a quadratic in disguise, because watch what I can do now. I'm going to subtract this guy over, and I'm going to rewrite this as 4 to the x squared minus, when I subtract 4 to the x times 4 over, I'm going to write it here in the middle. So I have 4 to the x squared minus 4 times 4 to the x minus 5 equals 0. And then this is where I make my let statement. Whatever is in the middle there, that's what I'm going to make my y. So I'm going to let y equal 4 to the x. And I happen to have a 4 to the x there too, so I'm going to substitute y in. So this is y squared minus 4y minus 5 equals 0. Now I'm going to factor here. Y minus 4, y minus 1. Oh, that's a big lie. Y minus 5. Hey, I caught it. Plus 1 equals 0. All right, and that's how you factor that guy. So now, from this point, I end up with y equals 5, y equals negative 1. Now, right here, I bring back in, what does y equal? Y is 4 to the x equals 5. So 4 to the x equals negative 1. Now, anything that's exponential can never equal a negative, so I'm going to reject that. And now this guy has two different ways I can write the answer. I can write it x equals, I should have changed my mind. I'm going to do log it first. This will be log, I'll do it the fast way last. Equals log 5. The x falls down in front. X times log 4 equals log 5. And divide both sides by log 4. So this is one answer that's acceptable. And this is the one you normally see places. So for those of you who keep doing it the other way, which is fine, you should know that this typically is what you see more often pop up. Another way you could do it is, right, x equals, this week we're going to bend it, so log base 4 of 5 equals x. So that's acceptable as well. However, you should be able to do it this way. That's how you usually see it, especially when you get to calculus. All right, that's your do now. We are going to have a quiz at some point where I'm going to give you guys a couple of questions. I'm trying to figure out the format and everything. But this is a little trickier than something I would ask you, but it's a good practice of skills. I would probably ask you something that's already kind of in this layout, and you have to go from here down. But I'm hoping you understood from here down. Up here is tricky. All right, Now today's lesson is based on this packet that I posted up on Google Classroom. It says exponential and log graphs. Now the best way for you guys to do this would either be to print out the packet or to write down the questions ahead of time. So, and like put one page in your notebook basically for each thing. That way you can see the equations better. What we're going to do in the video today is we're actually going to do numbers 2 and 3. So I'm not going to do the first one. I'm actually going to pick up on number 2. So if you need to get all that together, pause me. Either print out those worksheets or copy the equations down. So pause me. All right, so I hope you pause me, and what we're going to do now is graph this log graph. Now we did this the other day. I didn't give you an assignment to go along with it. You guys had done enough work last week, but today we're going to practice more. So let's take a look at this one. It says consider the function f of x equals the natural log of x plus 4 plus 2. And we want to find the domain and range of this thing and everything else. Personally, I'm going to jump right into graphing it, and that will help me do the domain and range. Now, we talked about on Friday, or Thursday actually, I posted the video, what the parent function would be. So when I look at this, I'm saying to myself, what would the parent function of this be? And the parent function would be y equals the natural log of x. That's the most basic graph of natural log you can get. So what I'm going to do is over here, I'm going to make an xy chart for the parent function. Y equals the natural log of x. Now, when you have a log equation, the easiest way to set up an xy chart is to bend it. So what would my base be? Would e, right? What would my exponent be? Y equals x. Right, so I'm going to make an xy chart here. Okay, now I'm going to pick 3 different things, right? I usually do 1 negative, 0, and 1 positive. Again, look what's in the exponent. Y, that's the variable where you're going to put your numbers. So I'm going to put negative 1, 0, 1. All right, what's anything to the 0 power? 1. What is e to the first power? E. Now we're not doing decimals. We're leaving it at e. We're going to use decimals. We're going to think about it in our head. But we're going to leave it like this. And e to the negative 1 is 1 over e. Okay. Now, this is the parent function. We need to graph this guy. So what I'm going to do now is take this and do the shifts. And I'm going to make that xy chart over here. So now I'm going to do, I'm just going to write f of x up here. F of x represents this guy, right? I'm going to do an x and y chart. And let's look at what the shifts are, right? This means I'm going to subtract 4 from the x's. So I'm going to go to the x column. So this is going to be 1 over e minus 4. And then what is 1 minus 4? Right? That's going to be negative 3. And this guy is going to be e minus 4. So that's the x column. Now, go back up to the equation they want us to graph. Plus 2 is hanging off on the end. That means I'm going to add 2 to the y values of my parent function. So negative 1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. Now, let's talk about asymptotes. What would the asymptote be for a basic log graph? So the asymptote is going to be x equals 0. What would the asymptote be for the new guy? What would be the new asymptote? Right? Now, notice this asymptote is x equals 0. So whatever you did to the x's, you're going to do the same thing to the asymptote equation. And we subtracted 4 from the x's. So my new asymptote is x equals negative 4. All right, so now I'm going to graph that. Now I love graphing on non-graph paper for these, just because it's easier to put stuff in. I'm going to put x equals negative 4. So let's see if I can put that in here. 1, 2, 3, 4. Negative 4, right? So we know we have an asymptote there. Okay, now let's talk about the other points we have to plot. This one's easy, so let's do that. At negative 3, we're going to put a dot on 2. So, 2. So at negative 3, I'm putting a dot on 2. Okay, now let's talk about what this would be. What is E approximately? Right? It's approximately 2.7, right? So 2.7 minus 4, or if you even want to think about it as 3 minus 4, it'd be negative 1 and change, right? 2.7 minus 4 would be what? Negative 1.3. So this would be negative 1.3 of 3. Approximately there, okay? Now let's talk about this one. Now, E is 2.7, or almost 3. So how you want to think about this, it's 1/3 minus 4, right? So 1/3 minus 4 would be negative 3 2/3 approximately. So negative 3 2/3 would be about here, and we're at 1. So see, I'm doing approximations. And I know I have to asymptote here. So all I'm going to do now, guys, is I'm going to connect these dots. And then this guy's going to continue asymptoting down. Boom! And that's how you can do it approximately with E. All right, now let's talk about domain and range. So I personally think it's easier to graph it first. Then you can easily tell what the domain and range is. The domain are the x's. Look at your x's. How far over to the left do we go? Notice it's a vertical asymptote, right? So that means it's going to be soft bracket negative 4. And how far to the right are we going? Notice the arrow. We're going forever. Okay. Range. Range is how low to how high. How low are we going? We're going down forever. How high are we going? We're going up forever. So my range is going to be negative infinity to infinity. Okay. Now, look what I want to do next. It says find the inverse of this guy. And then over here, I want to find the domain and range of the inverse. Now guys, how do you find inverses? You switch the x and the y. Well, what does the domain give me? X's. What does the range give me? Y's. Now we had talked about this once before. If I know the domain and range of the original, then I automatically know the domain and range of the inverses because all I have to do is flip-flop them. So my domain is going to be the range, or the y of the other one. And the range is going to be the domain. So I just flip-flop those. So I already know these answers because of these two before I even do the inverse. So keep things easy. All right. So what I'm going to do now is we want to find the inverse of this, of f of x. So I'm going to write it, instead of f of x equals, I'm just going to write it y equals natural log of x plus 4 plus 2. All right, now to find the inverse, we're going to switch the x and the y. And then we have to isolate the y again. So if we have to get the y out of there, what would I move first? Very good, the 2. So I'm going to subtract that over. All right, now guys, it's a log equation. This is Ben, right? You only see one log, you're going to Ben it. What's my base here? E, right? My base is E. Logs equal exponents, so this is my exponent, equals y plus 4. Now to get the y alone, I'm going to subtract over the 4. And then we got the y alone, but now I'm going to write it in the correct notation using f of x. So I'm going to do f of negative 1x. It means I found the inverse. It's going to be e to the x minus 2 minus 4. And that's the inverse. All right, so I did one log example with you guys. And now I'd like to do one exponential graph with you guys. All right, so let's take a look at this one. says a skydiver jumps from a reasonable height above the ground. The velocity of the skydiver at time t is given by v of t equals 80 minus negative 80 e raised to the negative t over 5, where t is measured in seconds and v of t is measured in feet per second. All right, what is the initial velocity of the skydiver? Now, initial means beginning. What time would that represent? Initial time. An initial time would be t equals 0. So what I want to do, and notice I'm not using a calculator, so you shouldn't be using calculators. I'm going to plug 0 into this equation and see what the initial velocity is. So I'm going to do 80 minus 80 e to the negative 0 over 5. So that's a negative 0 over 5. Well, what's the 0 in the numerator just become? Right, good, 0. So that becomes 80 minus 80 e to the 0. But what is e to the 0? Good, 1. Right. So what's 80 minus 80 going to make? Nothing. So my initial velocity of this guy is 0. Right. And that should make sense, because a skydiver, before he jumps, isn't moving. You don't count the plane. So that's why that answer is 0. Now what they want us to do is sketch this thing. So that's what we want to do. Now, first thing I'm going to do with this equation, I'm going to push it down a little more, is I'm going to put it in the right order. This thing is the same thing as saying negative 80 e to the negative t over 5 plus 80. That makes it a little easier to sketch. Right? Now, from this, I want to find the parent function. Now, the parent function is whatever the equation would be with everything else stripped away from it. Right? So if I stripped away all the other stuff, I'm going to write it up here, the parent function would just be y equals e to the x. All right? Y equals e to the x. So that's the parent function. So I'm going to make an xy chart for y equals e to the x. And I'm going to do the same thing. I'm going to pick 1 negative, 0, and 1 positive. Now, for this equation, look what's in the exponent, an x. So that means I'm putting my negative 1, 0, 1. Now, on the last examples, I used negative 2, 0, 2. It literally comes down to what my mood is. So that's, as long as you do 1 negative, 0, and 1 positive, you're always going to be in good shape. Now, let's plug that in. So e to the negative 1 is going to be 1 over e. E to the 0 is 1. And that will be e. Now, what I want to do is all of this to this. And there's one more change I want to make to this equation. And that's having to do with the exponent. See how the exponent's negative t over 5? So how I'm going to rewrite this now is negative 80 e to the negative 1/5 t plus 80. Because I want to know what's actually happening to that t. Right? Now, t in this scenario, guys, is which variable? Good. It's the x. Right? There it is, the x. All right, so I'm going to make a new xy chart. All right, so this is for v of t. Okay, I always go from left to right. So let's talk about the first thing I see. It's a negative. A negative out in front means I'm making the y's negative. So I'm going to take a look at the y values and we're going to negate them. So it's negative 1 over e, negative 1, negative e. All right. Now, that's the first thing I hit. The next thing I hit is 80. And that means now I want to multiply the new y's, these guys, by 80. So this is going to become negative 80 over e. This would be negative 80. And this would be negative 80. Okay. Next thing I come across is a negative here. Now I always handle the negative separate from the number. The negative means I want to negate the x's because this is touching the x. So I'm going to go through And I'm going to negate my x's. Okay. Now, 1/5, right? Now, whatever affects the x, we always do the opposite. So what I'm going to do now is these have to get multiplied by 5. So it becomes 5, 0, -5, right? So I'm actually going to cross these off because these became these. So this is my new xy chart. So effect on here. Good, it just affects the y. So I'm going to add 80 onto each of these. Let me get a different color. So this will now be negative 80 over e plus 80. This will be negative 80 plus 80, which would be 0. And this would be negative 80e plus 80. And now we have to graph this guy. Okay, so I'm graphing everything in the blue along with this. So, one final thing before I jump on here, because you know I love certain things. I need asymptotes. What's the asymptote for a regular exponential equation? And I'm hoping you're saying y equals 0. Okay. Now, what's my new asymptote? Now, y equals everything we did to the y's, we have to do to the asymptote equation. So let's check it out. We negated it, all right? So 0, you can't make negative. Then we multiplied it by 80. Okay, 0 times 80 is still 0. But then we added on 80. So my new asymptote is going to be y equals 80. So that's important because when I go up here, okay, I know we have to be up at 80. So what color do I want to do? Let's see what we go. That's going to be my horizontal asymptote way up there at 80. All right, now I'm going to graph the easy point first. 0, 0. Yay. Okay. Then check out this one. At x equals 5, right? 1, 2, 3, 4, 5. I'm at negative 80 over e plus 80. All right, now we're going to guesstimate this. I don't have a calculator. What is e approximately? 2.7, right? So what would be easier to use? 3, right? So up here, guys, right? What would negative 80 over 3 be approximately? Right? So watch. 3 goes into 80. How many times? 2, right? Which would be 6. Subtract that, you get 20. How many times does 3 go into 20? Approximately, right? 6 times. Which would make 18, so another 2. So it's about negative 26.2. So look what this is going to be. 80 minus approximately 26 is going to be what? What do you think? No, you guys can't answer. That's a joke. So think about it for a minute. 80 minus 26, you guys know I hate subtracting, is going to be 54, approximately, right? So 54 might be about there. We're just doing an approximate. So that's what it's going to do over here. Now let's talk about over here for a minute. What are we talking about here? Time. Because this is a word problem, and it has to do with a skydiver, right? In time, we can't actually have any negatives in this one, so we don't even need to graph this one. This would be my picture, right? And this point, because you made this chart and you have that right there, that's labeled basically with that. If you wanted to label it negative 80 over e plus 80, that's legit too. You could do that. All right, so that's our graph. Now, let's take a look at this. What is the equation of the horizontal asymptote as it goes to infinity? And look, by graphing it, we already answered this question. The horizontal asymptote, now I'm not going to use y because this equation didn't use y. This equation used v of t. So this would be v of t equals 80. So that would be the horizontal asymptote. So what's interesting, you guys, is for exponential equations, the asymptote is always y equals 0. And if I go back to the last one, in log equations, the asymptotes are always x equals. Okay. Last one. Give one physical limitation of the present model. What would be a real-world factor that's being ignored here? So there's more than one right answer here. We could say wind, right? We're not putting wind anywhere into this, or gravity hasn't been included into this equation. So any answer that was forgotten out of this basic question is a good answer for D. All right, so I did the two worst ones in this packet with you guys. I did the two that had to do with E, and this was a very complicated question because I had multiple shifts going on. I would love for you guys for homework to try number 1 and the last one, number 4 in this packet. So that's your homework. And I want you to practice it. What I'm going to do in the next video is me going through those, and we'll see how well you did. All right? So there's nothing to submit this time. Just make sure you practice those without me, see how close you get. You are going to have a quiz on these at some point where you're going to have to submit something for me. All right, guys.